15-1 video you are watching. Review nomenclature. Acids and bases properties of. Acids and bases Arrhenius. Acids and bases strong and weak. And reactions, neutralization and acid. So, chapter 15. First of two that are related to acids and bases. So, first thing, review your nomenclature for writing names and formulas for acids. You have to know how to write your formulas. Okay, now, the naming rules. Remember, if you're given the formula, you need to look at the anion, and you have to know the name of the anion correctly. Okay, so go back and review your polyatomic ions if you need to review them again. Remember, anions can only end in "ide," "ite," or "ate." Okay, and use the following rules. "I" turns into hydro-ic, "ite" turns into "us," and "ate" becomes "ic" in terms of the names. Okay, and writing formulas. The acid names will end in either "ic" or "us," but watch for a prefix. Okay, so use the name to figure out the name and thus the formula of the anion, and write out the anion, make sure you have the charge with it, combine it with H+, and then make sure you balance out the charges. Okay, basically the only thing you're ever going to need more than one of is going to be the H+ ion when you're writing your formulas. Okay, so write the names and formulas for these things. Okay, stop the video, write these out, and then come back and check. Okay, first one here, ClO3, this is chlorate, so that means this must be chloric acid. Okay, nitric acid, it came from 8. Nitrate is NO3 1-, combine it with the H+, that means your acid will be HNO3, and don't forget your AQ at the end. Sulfurous acid, us, came from ite. That means it came from sulfite, which is SO3 2-, combine it with H+, and your formula is going to be H2SO3. Don't forget, no charges on your formulas ever. Okay, and HBr. Br is bromide, so ide means you have to do hydro and then ic at the end, and it's going to be hydrobromic acid. Okay, if you got any of these wrong, go back and practice. So, properties of acids. Okay. Aqueous solutions. When an acid is dissolved in water, it will have a sour taste. Okay. All your sour tasting foods are acidic. Okay. They will react with active metals. Active metals are basically the ones that are in groups 1, group 2. Okay. And this reaction is basically known as being corrosive. And they always release a gas, and that gas is hydrogen gas. They will dissolve organic matter, like skin. So not a good idea to get an acid on your skin. If it does get on there, wash it off. They will react with bases and produce salts and water. Okay. And they will conduct electricity, which means they do produce ions, even though these are molecules. So that means these will basically ionize. Okay. Now, a good way to test is not to go and taste it, because that may be the last thing you end up tasting. Okay, so one way you can use is something called litmus paper. Okay, and you probably use this in elementary school, junior high school. So, which color litmus paper do you end up using? Okay, well, use the blue one. It should turn red, and then that means it's an acid. Okay, so maybe you can figure out some way to remember that. Okay, now make sure you read common uses for acids found on these pages in the book. They are on the test. They will ask you, this is for this substance, what acid is used to make it, so make sure you know it. Okay, now, what are these things called? Bases. Okay, they are going to have, their solutions will taste bitter. Okay, and don't ask me what's the difference between bitter and sour. That's like asking what does red look like. Okay. Bases are caustic. Okay, caustic means they will attack skin and tissues and dissolve them. Okay, now a base that you guys used, and well, they will feel slippery as a result. Okay, a base that you guys used in the penny lab was sodium hydroxide. Okay, now we told you if it got on your hands, you need to wash it off because it would feel slippery. Okay, the reason why it felt slippery is basically it was dissolving the fat cells in your skin. Okay, these will also conduct electricity, which means they will produce ions in solution. Okay, now litmus paper, again, probably not a good idea to go and taste it. Okay, because again, that might be the last thing that you end up tasting. Okay, so for this one, instead of using the blue litmus paper, you use the red litmus paper. Okay, and it turns blue and you get a base. So RBB or okay, now another thing that we can use is something called phenolphthalein. Okay, this is a common indicator. Now the difference between this is you actually put this into the basic solution. Here you dip it in and you remove it, the litmus paper. This one, it stays in the solution. Okay, phenolphthalein is pretty much going to be clear in an acidic solution or in neutral solution. But once you put it into a solution that's basic, it turns a really bright pink. Okay, so what makes an acid and a base a base? Okay, well, a couple different people tried to go and determine definitions of what makes something an acid. So first person was Arrhenius. Okay, he said if an acid is an acid, it's because it produces H plus when you dissolve it into water. Okay, so that's why we got the aqueous there. Okay. Arrhenius also said, well, if a substance is a base, what they all have in common is they will produce hydroxide ions when you put them into water. Okay. So sodium hydroxide is a base. Why? When you dump it into water, it breaks up, it dissociates, and turns into hydroxide ions. Okay. Now, HCl, hydrochloric acid, obviously an acid from the name. It does not really produce H plus ions. Okay? What happens is the H plus ion latches onto water. This hydrogen ion really does not exist as a free ion. It latches onto H2O and produces hydronium ion. Okay? So this ion, the hydrogen ion, doesn't really exist by itself when it's dissolved in water. Okay? So it actually produces hydronium ion, but we're going to consider these two things to be exactly the same. Okay, so whenever we talk about H+, we're really talking about hydronium ion. Okay, now, strong and weak acids and bases. This term strong means exactly the same as when we were talking about electrolytes. Okay, strong electrolytes will completely ionize or dissociate. Okay, so all of the molecule or ionic compound breaks up. Okay, if it's weak, only a small amount of what is dissolved will actually ionize, and it has to be ionization, not dissociation. Okay, so how do you know if an acid's a strong acid or a weak acid? You have to memorize the strong acids. If it's not one of these, then it's a weak acid. Okay, so make sure you know the names of these things. Write them down. This is sulfuric acid. This is nitric acid. This is perchloric acid. Hydrochloric acid, hydrobromic, hydroiodic. Okay, notice Cl, Br, I. Those are halogens. Okay, but notice what's not there. HF is not there. Now, what does this first H mean only for H2SO4? Okay, H2SO4, you dump it into water, it will break up into one H+, and then the other H stays on there. Okay, so the arrow only goes one way. It's a total ionization. Okay, and actually, remember, it's not really H+, it actually reacts with water, and so you actually get H3O+. Okay, now, what about the second one? This bisulfate or hydrogen sulfate ion breaks up, but it's a weak dissociation. Okay, H+ and or weak ionization, SO4 2-. So you get a little bit more, but not much more coming off of this. So you don't get two H's breaking up, you only get one H breaking up. Okay. The strong bases, you need to memorize these too. Okay. All the group 1 hydroxides, so sodium, lithium, potassium, etc. Calcium hydroxide, strontium hydroxide, barium hydroxide. Okay. Now, this one here is only slightly soluble. Okay. So, even though it doesn't dissolve very much, whatever does dissolve totally dissociates. So that's why it's considered to be a strong base. Okay, so what are the weak acids and bases? It's acid or base that is not one of the strong ones listed. So make sure you memorize them. Okay, so here's an example of a weak acid. Okay, HCN, hydrocyanic acid, because this right here is cyanide. Okay, when you dump it into water, it reacts. It's still an acid. It still produces the H plus comes off of that, attaches to water, so we still get hydronium, but notice it's a double arrow, a reversible. Okay, so we get an equilibrium, and the left side is heavily favored. So you only get a little bit of that and a little bit of that. Most of it stays together as the molecule. Okay, NH3, ammonia. Don't forget this one. Okay, now the water does the opposite here. It donates an H plus to the ammonia. That turns into ammonium ion and hydroxide. Okay, so why is that a base? Because you produce hydroxide. And again, double arrow, but the equilibrium still heavily favors the left side. So very little of the ammonia actually reacts with water. Okay, both equilibriums lie to the left always in a weak acid or a weak base. Okay, now what are some neutralizations that take place, or some reactions that take place? Okay, we have acid reactions and neutralization reactions. Okay, so the first thing we look at, a neutralization reaction. It has to be an Arrhenius acid with an Arrhenius base. Okay, just because you have an acid and base doesn't mean it's a neutralization. You have to produce water and a salt. Okay, now these are also exothermic, so they produce heat. If you have a lot of acid, a lot of base, this can be a really dangerous reaction because you can produce the heat really quickly and the whole thing can basically boil over or sometimes explode. Okay, now what's this salt thing? Okay, the salt is basically what's formed from the cation of the base and the anion of the acid. Okay, so it's the stuff that's left over, the stuff that didn't make the water. Okay, so here's an example. Here's our acid, here's a base. Why is this a neutralization reaction? Because we have water. Now, where did the salt come from? Okay, this came from the fact that that breaks up into H plus perchlorate, ClO4 minus, and that's Sr2 plus, and hydroxide, OH minus. Okay, so that and that made the water. So this makes your salt. The strontium ion and the perchlorate ion. Don't forget, always write the cation first. Okay, now balance it. Okay, easy way to balance this equation. Look how many H's are in the acid. Look at how many OH's are in the base. Okay, there's two of them here. So make sure the H's and the OH's have to combine in a 1-to-1 ratio to produce water. Okay, so I got two H's. I need two, or sorry, I have two OH's. I need two H's, and that will give me two waters. So basically I'm saying, okay, I got two H's coming off of that. I have two OH's coming off of that. So that 2 to 2 will give me two waters. So I put a 2 there, and then it'll balance. The salt will always have a coefficient of 1. Okay, what about this one here? Okay, again, break it up. You got H plus, PO4 3 minus, K plus, OH minus. Okay, so we know we're going to get water. That comes from the H and the OH. Okay, your salt is going to be K3, PO4. Okay, combine that with that. And to balance it, I got 3 H's here, only 1 OH here. So I put 3 there. That'll give me 3 H's, 3 OH's, and I get 3 waters. Okay, other acid reactions that can take place. Some of these you guys have seen before from the first semester. If you have a metal with an acid, you produce hydrogen gas and you get a metallic salt. Okay, so an example, aluminum with HCl. This is basically a single replacement reaction. Okay, now this has to turn into an ion. So aluminum, column 3, 3 plus, HCl, you have H plus and Cl minus. This is going to turn into the H2. Okay, and then what's left over to make the salt? The ions, Al3 plus and Cl minus. So Al, Cl3. Okay, then balance it. Okay, careful. The H's and the Cl's have to be in the same spot. So I got 2 and I got 3, so make them 6. 3 there, 2 there, and 2 there. Okay, now, metallic carbonates plus an acid will produce CO2, H2O, and the metallic salt. Okay, so here's a metallic carbonate. That's your carbonate. There's your metal with your acid. Okay, so we know we're going to get CO2, H2O. Okay, what's the salt going to be? Well, it has to be the metal, which is Mg2 plus, and this went to make the H2O. So the anion has to be the one that's going to combine with the metallic cation. So that's going to be perchlorate, ClO4, 1 minus. So we should get Mg, ClO4, 2, because you got a 2 here. Okay. Then when you balance it, I need two perchlorates, and then that's basically it. It's balanced. Okay, so try these. Okay, these are all one of those reactions that you saw before. Okay, they will all fall under one of these types of reactions. Okay, so try them. Stop, copy them, write them out, and come back and check. Okay, this first one you should have got H2O plus CaCN2, and then balance it. 2 there, 2 there. This next one you should have gotten H2O plus CO2 plus KNO3, and then to balance it you need 2 there and 2 there. Okay. For this one you should have gotten H2 plus CaBr2, and to balance this you need a 2 there. Okay. And for this one, CO2, H2O, and Na2, SO4. Okay, and its balance is written. So, here's your review question. Which of these is a neutralization reaction?